Okay, in this class I'm going to look at a couple of different ways to talk about how a data is spread out or how it's dispersed. So I'm talking about measures of spread or measures of dispersion. And the first measure of dispersion we're going to talk about is called the range. Very simply, the range of a data set is the difference between the biggest and the smallest values in the data set. Or if you arrange the data set in ascending order, the difference between the first and the last. Okay, but in order to find the range, all we have to do is look for the smallest value and the biggest value. So in this data set here, we're asked to find the range of the following unordered data set. It's not in order, but I can see straight away the largest value is 11, the smallest value is 2. So if I was to put them in order, the first value would be 2, the last would be 11. The range is the difference between those two values. So it's just 11 subtract 2, which is 9. It's as simple as that. Okay? Find the range of the following unordered data sets and identify the more consistent student. Again, that word consistent, what does that, we're not talking about the better student, but the person who scores most consistently in and around the same value. So if I look at John and Mary's scores, John 59, 68, 60, 63, 70, you can see John's lowest scores in maths, 59. What a disgrace. And highest score there in 70. So the range for John's score is 70 subtract 59, which is 11. So John's range is 11 in this case. Mary, 65, 89, 93, 80, 50. You can see she's a low score in 50, but a high score in Irish at 93. So Mary's range is 93 subtract 50, which is 43. So what way do we interpret that? Well, we might say that John is a more consistent student because he's scoring, more consistently, numbers that are closer together. Mary's data is more spread out. So even though she's scoring higher than him in Irish, English, French, and maths, she's possibly not as consistent as him because there's a greater range in her results. Okay, so you might say John is a more consistent student in this case. That does not mean a better student. In fact, in 4 of the 5 subjects listed, Mary is outscoring John. Okay, so that's range and how we interpret it. Another measure of spread I want to talk about, and only the second one in this lesson, is something called the interquartile range. And the interquartile range is simply the difference between the upper and lower quartiles. Okay, remember we looked in the last lesson at finding the quartiles of a data set. We've got an ordered data set. Here we're asked to find the interquartile range. The interquartile range is the difference between the first and the last quartile, or the lower and the upper quartile. So one thing, I'm going to just count the number of values in here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 values in here. That's an even number. So the first, I'm going to look at my 3 quartiles, which we call, I'll write them up here, Q1, Q2, and Q3. They're my 3 quartiles. The first quartile I'm going to find is Q2, which is, also known as the median. So to find my quartiles, I just look at the centermost value. Now, because there's an even numbers, there's no single value in the middle. In fact, there's kind of 2 values in the middle. There's 4 numbers to the left of 11, 4 numbers to the right of 13. So my central value, if you like, will be exactly halfway between 11 and 13. So my medium here is the number that's exactly halfway between 11 and 13. That's the number 12. Okay, and we said, again, the median always divides the data into a lower set and an upper set. The lower quartile, using this method, the median method, the lower quartile, is just the median of the lower set. So there's 5 numbers here in the lower set. The median is the middle one, which is 5. So that's my lower quartile. In the upper set, 5 entries again. The median will be the 3rd entry in there. So of the lower set, 5, that's the median of the lower set, which we call the first quartile. First quartile is just the median of the lower set, or the lower quartile. So the lower quartile here is 5. The upper quartile is here the median of the upper set, which is 19. Okay, there are my quartiles. What am I asked to find? I'm asked to find my interquartile range. And I'll just stick it in here. The interquartile range is defined as being Q3 minus Q1. The upper quartile, subtract the lower quartile. 19 subtract 5 is 14. And again, that's just another way of talking about how spread out the data is. So we're talking about measures of dispersion, measures of spread. The range is one, the interquartile range is the other. Which is better? Well, the range is useful really only if there are no outliers. Items that look like they don't belong. Things that are way bigger than everything else, or way smaller than everything else, or way out on their own. They tend to be called, they are called outliers. If there's no outliers, the range is a great measure of dispersion. However, if there are outliers, well, the range is not a great measure of dispersion because it can be very affected by those outliers. So if there are outliers, I would tend to use the interquartile range as a much better measure of how spread out the data are. So, briefly, if there are no outliers, range is fine. If there are outliers, interquartile range is better. Excuse me. Find the interquartile range of this unordered data set. That says ordered. Of course, that should be unordered. It's not in order, so I'm going to find the interquartile range. First thing, put it in order. 2, 3, 4, 6, 7, 9, 11. Find the 3 quartiles, Q1, Q2, Q3, Q1, Q2, Q3. Q2 is the median, the second quartile, which in this case there are 7 values in my list, so there's my median. So Q2, my median value here is 6. Q1 is the median of this lower set here, and there's 3 items in the lower set. Notice we don't include the 6 here in my lower set. It's 2, 3, and 4. There's only 3 values in here. There's my lower quartile. My upper quartile is going to be the median of the upper set. So 3 is my lower quartile, 9 is my upper quartile. My interquartile range is going to be the upper quartile 9, subtract the lower quartile 3, which is 6. Okay? That's kind of saying that this data 6 is less spread out than this data that had an interquartile range of 14. That's really what it's saying. A smaller interquartile range would suggest it's less spread out. Okay, let me go through one more example. Find the interquartile range of the following ordered data set. Again, that is not ordered. Unordered data set. Step 1, put it in order. 2, 4, 6, 7, 8, 9, 11, and 13. There are 1, 2, 3, 4, 5, 6, 7, 8 data points in that data set. We're going to find the 3 quartiles, Q1, Q2, Q3, and from that we'll be able to figure out what the interquartile range is. Notice IQR is universally accepted abbreviation for the interquartile range. Okay, there are 8 values in the data set, so the median, the second quartile, is going to be the number that's exactly halfway between 7 and 8. So you can take their average, you'll find it's 7.5 or 7.5. My lower data set now consists of these 4 numbers in here. My lower quartile will be the number that's halfway between 4 and 6. My upper data set now is these 4 numbers over here. My upper quartile will be the number that's halfway, exactly halfway between 9 and 11. So my lower quartile between 4 and 6, that's 5. My upper quartile halfway between 9 and 11, that's 10. My interquartile range will be 10, the upper quartile minus 5, the lower quartile, so it's going to be 5 units. Okay, and that gives me a measure of dispersion, how spread out. Okay, range is a good measure of dispersion. If there are no outliers within the data set, it's a really good measure of dispersion. If there are outliers, it's a terrible measure of dispersion, so we would switch to interquartile range in that case. Okay, range, interquartile range, make sure you know them.